Hello again, this is Mr. Behill. Today we're going to be talking about the slope-intercept form. And we have the definition of it right here for you. So if a line has a slope of m, meaning just a number, and the y-intercept for the line is the point 0b, then we can write the equation for the line in what is called slope-intercept form thusly. Y equals m times x plus b. And this should be pretty much a review for you. We covered this a bunch when we did the big graphs activity, and you also covered this extensively in 7th grade last year. So we're just going to work through a little example here for how to write the equation for a line in slope-intercept form. So suppose we're given 2 points, 2, 5, and 7, 2. I've got those ones graphed right here. If we want to write the equation for this line in slope-intercept form, well, we need to know, obviously, the slope and the y-intercept. And we could figure out the slope here. Actually, let me just draw in the line. I've got my handy-dandy ruler here. And it looks like it'll be through about like that. And this is just a sketch, so it's not going to be perfect, of course. There we go. And we can see here, if we want to calculate the slope just using rise over run, drawing our little slope triangle, and we see that the slope should be able to go down 1, 2, 3. So the rise is -3, and then we go to the right, 1, 2, 3, 4, 5. There's the rise, there's the run, there's our slope. And looks to me like this y-intercept is, well, let's hear 1, 2, 3, 4, 5, 6. Yeah, y-intercept is 6, so we should just write it down, right? Hold on. This was just a sketch. Probably not hugely accurate. But let's go through the process here and see what the heck this really is. So first off, we need to find the slope. And we can do it one of two ways. We already did here with the rise and the run, and this is perfectly trustworthy. Yeah, the slope is -3 over 5. Or we could use the slope formula. M is equal to y2, the y-coordinate of the second point, minus y1, 5, the y-coordinate of the first point, over x2 minus x1. And so 2 minus 5 is, of course, -3. 7 minus 2 is 5. Yes, that is our slope, -3/5. Fantastic. But we already know how to do that. Next thing, we need to find the y-intercept. And eyeballing it is not going to be good enough here. What we need to do is make use of one of these 2 points. Because the basic idea here is that we're going to write an equation in the form y is equal to m times x plus b. Well, we know what m is, -3/5. We can put that in. And now what we have to do is make use of one of these 2 points. Because thinking back to what an equation for a line really is, in a way it's a name for this collection of points. Meaning that if we take a point on this line and plug it into this equation, the x-coordinate right there and the y-coordinate right there, what we'll get is a true statement out. So if we replace this x with this x-coordinate and this y with this y-coordinate, then we better have a true statement. Meaning that the only thing we won't know about it is b. And we can solve the equation for b. And that's how we're going to do it. So we rewrite this. We just plug in this y-coordinate here for y equals -3/5 times the x-coordinate 2 plus b. And so, of course, -3/5 times 2 is -6/5. And now all we have to do is solve for b. Easy enough to do. We just add 6/5 to both sides. And of course, these will cancel out. And then we'll be left with just b on the right. And we got 5 plus 6/5. which is, well, 5 is 25 fifths, plus another 6 fifths would be 31 fifths. And that's what our y-intercept is. Well, it's at least the y-coordinate of the y-intercept. And let's see here, 31 fifths is, that's 6 and 1 fifths in mixed numbers, which are okay when you're doing graphing type stuff because it's much easier to think about, oh, it's 6 and a fifth as opposed to, oh wait, how much is 31 fifths? So you get the idea there, right? And so yes, that's B, and so our equation is y is equal to negative 3 fifths x plus 31 fifths. And that is our equation in slope-intercept form. If you want to check to see if we did that right, we could always go to our handy-dandy calculator and just type this equation in. Y is equal to negative 3 fifths times x plus 31 fifths. Maybe we go to the table and let's see here. Oh, wouldn't you know it? Yeah, there's the 0.25, which was supposed to be on our line, and there's the 0.72, which was supposed to be on our line. And since those 2 points are on this or in this table, we know that we did it right. Okay. So with that, I'm just going to leave you with a couple of practice problems. So now, but while it's fresh in your mind, you might want to go back and watch the example again and then work through these two problems. Writing the equation in slope-intercept form for the line passes through these 2 points, and then do these ones. And you can use a graphing utility or on your computer to check to see if you did it right. I'll see you in class.